Okay, so here are all my light rays coming into my concave mirror. My curved mirror. It's a spherical mirror, but we're on the curved side. We're on the inside of the curve, reflecting off this surface. That's called the concave surface because you're inside the cave. You can see we are. Here's my radius, R. All the lines are coming here at the focus of F, which is 1/2 of R. Yay. So now, instead of bringing parallel lines in, what if I have like a tree? Now, the light that's coming off the tree, all the parallel lights from that tree, well, since they're all parallel, they're all coming right through the focus, which also means that they are still paraxial, which is nice. So, but I want to know if this tree is going to show up somewhere over here. Am I going to get some sort of image of the tree? So the light that's coming off, I could pick all places. I'm going to pick the top of the tree. So let's take the, let's just get one ray here. And now let's bring in the ray from the top of the, it would come over, it's going to hit that, and look, it goes, well, goes through the focus because it's a parallel ray. The parallel rays go through the focus. So let's draw it out. All right, I'm going to move, let's get my little drawing, where's my pencil, here we go. So the ray that comes from here hits the mirror and then comes through the focus. Let's put my mirror back on there. Now, ooh, look at that, I can't get it right back in the same spot. Come on, get in there. Now, what about the ray? Now, there's another ray because a light's spraying all through here. What if the light comes through the focus from the top of the tree? From the top of the tree through the focus. There we go. It's hitting there. Now, we know that any light that comes in parallel has to go through the focus. So light that comes, because light must go, but light that comes through the focus has to come out parallel to the principal axis. So here we go. Let's draw this one out. There, and that's going to hit there. It's going to go through the focus, and then it's going to come out parallel. Now I've got, oh look, they're meeting at a different point over here, but let's just make sure. Let's hit one more thing here. Let's see this. What about this center point, this radius with a, what happens when my light goes through the center point here? If I can line it up right. Oh, well, it's not on the curve anymore. There we go. So you can see that it's, when it goes through the center point, it follows the radius of the curvature. So it follows the radius. So that means the radius at the circle out here has a incident angle of 0. So it has a reflected angle of 0 and just gets reflected back onto itself. So let's draw this one back out. So starting at the top, going through the radius. It's going to hit and then come back out. So let's take a look at where we ended up. So ray number 1 comes in parallel, goes through the focus. Ray number 2 comes in through the focus, comes out parallel. Ray number 3 goes through the center and back onto itself, and they all meet right here. So right there becomes something special. That is where all the light from the top of the tree came from. So that means there's a little image of a tree right here It's not very big. So all the light that used to be right here that hits this comes all right back here. So that's the top of the tree. The bottom of the tree just ends up right here at the bottom. And notice it's flipped upside down. There is light here, so this is what's known as a real image, because there's really light there. You can almost read it. So this is ray tracing a concave mirror when you are outside the focal length. So to recap, parallel lines go through the focus, lines through the focus come out parallel, lines through the center come back out where they came from.